Okay, everybody, today we're going to talk about voltage, and we're going to start by talking about Alessandro Volta, who is the guy that I guess voltage is named after. He's an Italian scientist, or was an Italian scientist. His full name was Alessandro Giuseppe Antonio Anastasia Volta. You don't have to remember all that. I just really like the old scientist names because they're all super crazy. Um, he created the first electrical battery, and his work went against the theory that was prevalent at the time that electricity was only generated by living beings. Uh, his work was basically the beginning of electrochemistry. So the idea that you can make, or you can study electricity and make electricity through chemistry, through inorganic things versus organic things. So voltage is what we're interested in here. Voltage is the difference in electric potential between 2 points. It's also called the electrical potential difference. And this was always a term that confused me in physics and in science, was potential difference. And basically what that means is uh, there's something that will create a force, or something that will incentivize a force or a release of energy. And it kind of depends what you're talking about. But in this case, voltage, it's the reason that a charge moves through a conductor in a circuit. If you've got excuse me, if you've got an intense negative at this node and an intense positive at this node, when you connect those, there's going to be a current. There's going to be a flow of electrons or a flow of ions, as we talked about before. And the higher the voltage, the higher the difference, the higher the current will be, the more the flow will happen. So I know this is kind of a confusing term for some people because it confused me. So if you do have issues with this term, come talk to me, or poke around the internet yourself a little bit. The Simple English Wikipedia is a really good start to jump off of. And try and see if you can understand the idea of a potential difference. Some people like to use an analogy. Sometimes it confuses people, but I'll use it. If it confuses you, ignore it and move on. But the analogy of if you're holding a rock at the top of a hill, like a round boulder at the top of a hill, that it has the potential energy of rolling down that hill, and you're holding it back, right? It's got nowhere to go. As soon as you let go, that potential energy is released and it rolls down the hill. There's a similar thing here. We've got a potential energy. It just doesn't have anywhere to go. As soon as we connect those things, now it has somewhere to go and it flows and it creates a current. So voltage, unlike charge, is always measured between 2 points because we're basically comparing. It's the potential difference. We're comparing what's the difference between this point and this point. Or if you had a circuit, what's the difference between the beginning of the circuit and the end of the circuit. And the standard unit is a volt, capital V, big V. Let's put that in there. It was named after our buddy there, Alessandro Volta. Okay, so George Ohm is a guy who's also important in this conversation. He was a German scientist who came after Volta, and he did a lot of work based off of Volta's past work. And he discovered that there's a direct proportionality between voltage and current. So his idea was that you can use one to predict the other. They behave in a predictable fashion. And his resistance, or his idea of resistance, was that it's a measure of how much a substance opposes the flow of electrons through it. So if you've got something with a very high resistance, it doesn't allow electrons to flow through it very well. So when we talk about insulators versus conductors, oftentimes conductors might have a higher resistance. Whereas if we go to the other end of the spectrum to a superconductor, which are pretty special materials, you can check them out if you want online, they're pretty cool. Superconductors have little to no resistance. Um, I think, I'm not positive, but I think a material with no resistance doesn't exist yet. Because if it did, you could potentially transfer electricity and all that kind of stuff with no loss, which would be pretty amazing. So resistance, the most common place you're going to see it in your home is anything that's electrical that creates heat. Very often you'll probably see resistors in those. So if you're thinking like an electrical element on a stove or a hair dryer or a toaster, they all have these elements that heat up. And basically what's being done there is electricity, a current, is being forced through something that has a high resistance. And as we force more electricity through there, the electrons slow down and they start generating heat. So the higher the resistance, the slower charges will move through. And in this case, it ends up generating heat. The standard unit is the ohm, named after George Ohm, and it's represented by a Greek omega symbol, just like this. So when you draw this, you don't have to draw these little things. I'll draw them when we use some examples. And you might have seen these before too, if you were like, I don't know, broke open your phone or played with a circuit board or something. These are resistors, they're called. And you basically attach these into a circuit. So one end of your circuit will attach at this end, one end will attach at this end. And in between here, it will resist the passage of electricity. And that can help kind of regulate how much electricity is put into certain parts of a more complex circuit, basically. So you can have a single power source, and then certain parts of it only get a certain amount of electricity. And those little stripes on them, you'll notice they're different on each of them. Those stripes, there's a universal code for these that basically says how strong that resistor is. Oh yeah, and we've got some measuring tools that we should kind of be made aware of. So current is measured by an ammeter, measured amps. You'll notice that's this one here. It's got an A right there because it's measuring amps. Voltage is measured by a voltmeter. It looks almost the same, but you've got a V there because it's measuring volts. And you'll hook up your circuit or whatever you want to measure to these two nodes here, and this needle will spring up and kind of show you a reading. And then there's also an ohmmeter to measure resistance. And you can see that this this black kind of pen here has a metal tip on it, and this red pen has a metal tip on it, and you put those on the ends or on each side of what you want to measure the resistance of, and it measures the resistance across that thing. So you'll notice it's hard to tell in this picture. Wait, I guess I can just do this. There's a little resistor right there, and they're measuring the resistance of that resistor. So let's talk about Ohm's law. This is kind of the culmination of this discussion. Ohm's law is a mathematical relationship between voltage, current, and resistance. I hope you guys are used to seeing these triangles by now. The formula is voltage equals current times resistance. I like this triangle because it tells you what they're measured in, and it gives you the symbol for each one. So if you feel more comfortable kind of paying attention to that one, go for it. And as we've seen before, when you've got a formula with three different variables, you can rearrange them in multiple ways to solve for any one variable as long as you know the other two. So why don't we go to this here, and we'll do a couple examples. So if there are 7 amps running through a 3 ohm resistor, well, we need to identify that we've got, well, let me make sure I'm on the proper layer here. Seven amps is important, 3 ohms is important, and we're looking for the voltage. What will be the voltage across the resistor? So we're going V equals I times R here. So we're not told the voltage. Our current, we know, is measured in amps. And our resistance, we know, is measured in ohms. So our voltage equals 7 times 3 equals 21 volts. So that would be our voltage across the resistor. And remember, voltage is the potential difference. That's why it says it's across the resistor. So it's being measured at 2 points. So our potential difference or our voltage is 21 volts. And this one is asking for what is the current. So we'll say, we'll rearrange this, right? Current equals I equals V over R. And we say, what is voltage here? 10 volts across a 5 ohm resistor. And we have 2 amps as our final answer. Oops. Let's try one more. If there are 40 volts and 5 amps running through an electrical circuit, what is the resistance of the circuit? Well, we're looking for resistance. So we would say R equals, we'd go over here, V over I. V over I. And let's start plugging in our numbers. So volts, we have 40. Amps, we have 5. 40 divided by 5, we get 8. And this is where you can either write it as, you can write it like that if you want, 8 ohms, or probably more commonly, you'll see your little omega there, okay? And my omegas look bad, but you're allowed to draw them like that, okay? You don't have to do the like super fancy light bulb looking omegas. You can just do a line here, a little loopy-doo, another line. I've never been marked down for it. I've seen a lot of people do it like that. I don't know. I think that's the easiest. So those are 3 different examples, guys, of how you can do, how you can solve for the 3 different parts. And that's it for today. Not too long. We'll get you to do a couple questions of your own. Have a good one.